Exercises on strings. I assume this morning that you've read the chapter and done the videos in Python for everybody. First task is to create a string my_name containing your name, including your first name and last name separated by a single blank space. Then put the second character of your name in the variable second and print second. Okay? Stop the video, do that, and come back, and we'll go on. Okay, you're back. I assume you've done the work. So here's my answer. My name is Harold blank space Nelson. Second is my name, index position 1, because remember that string indexing starts with position 0. There's position 0, there's position 1. And I print second, and I get A. Okay, on to the next exercise. Compute and print the length of the string my_name. This is just really asking you to recall the name of the function which does that in Python. So stop the video and do your work, then come back. Okay, you're back. I assume you've done this. And the function's name is len. So I print the len of my name, and it is 13. Okay. Extract the last character of my name and print it. Use a positive index. So stop the video, do your work, and come back. Okay, you're back. I assumed you stopped the video and did your work. And to get the last character in my name, I print my name indexed at 12, which is one less than the length of the name, and that's because indexing starts at 0. I'll keep repeating that point a couple more times probably. Okay, next exercise. Use a while loop to print each character of my name. Okay, stop the video, do your work, and then come back. Okay, you're back. I assume you've done your work. So I start by getting the value of length. Length is len of my name. Position is 0, so I start with the thing that I want to start with. Remember, this is one of the possible variants on the while loop theme. And while position is less than length, print my name at position, so it would start off with the thing at position 0, because that would be the first value that pause has when you enter the loop. It would print the H, and then it would increment the value of pause and then go on. And this is what it did. Did yours work too? I hope it worked. Okay. Let's go on to, you can stop the video and look at this if you want before you go on to the next exercise. Make sure you understand why that while loop worked. Okay, let's go on to the next exercise. Use a for loop and the in operator to repeat the exercise above. Okay, stop the video, do your work, and come back and look. Okay, you're back. I assume that you did your work. Let's go on, look at it. For a letter in my name, print letter. Gosh, that's simple compared to the while loop. For loops with this kind of indexing are so much easier to do. This is because a string is iterable. You can iterate directly on a string. You don't have to refer to the things in it by position. This construct for letter in my name just automatically starts at the beginning and goes to the end, and you're done. Whoopee. Okay? Well, there's not much to look at here, but just to marvel at how really simple it is doing it this way. So let's go on to the next exercise. Create and print a string straddle consisting of the last character of your first name, the blank space, and the first character of your last name. Use slicing. And of course, you're going to have to look at your name carefully and figure out which index you need to refer to these two characters and the one in between, the blank space. So stop the video, do your work, then come back. Okay, you're back. I assume that you have done your work. Let's look at the answer. In my case, the proper indexes were 5 and 8. So what I get are the things in my underscore name at positions 5, 6, and 7 because 8 is not included. So I get the D, which was the end of my first name, and the capital N, which was the beginning of my last name. Okay. Your answer, of course, will be different because your name isn't Harold Nelson. You might have got 5:8 anyway, but not by my name. Okay. Let's go on to the next exercise. So that relied on your manually counting. That's not a real great programming exercise. Let's make it a little bit more of a programming exercise. Let's manually locate the index of the blank space and call it blank underscore pos. Use this variable to get strings first name and last name using slice specifications with only one number. Print the values of blank underscore pos, first underscore name, and last underscore name. Okay, so stop the video, do your work, come back. You're back. I assume you've done your work. So let's go on. I manually located the blank position at index location 6. So first name is my name up to but not including blank underscore pos. And last name is my name starting with blank underscore pos plus 1, not blank underscore pos, but 1 beyond blank underscore pos, colon, to the end of the string. Okay? So the first name was Harold, the last name was Nelson, blank underscore pos was 6. Okay, look at your code, look at your results. Did you get the right thing? Okay, let's go on to the next exercise. So use string functions to do each of the following and print the results. Create lower underscore name, your name in lowercase letters, cap underscore name, your name capitalized, starting from name underscore lower, and create upper underscore name, your name in uppercase, starting from lower underscore name. Okay, this is really just asking you to look up the functions which do that, or the string methods which do this. Okay, stop the video and do your work and come back and look at my answer. Okay, you're back. I assume that means that you have done your thing. Let's take a look. Lower underscore name is my underscore name dot lower. And this is what it did. I printed lower underscore name. Note that the H and the N both were converted to lowercase numbers. Cap underscore name is lower underscore name dot capitalize. That's the method. And print cap underscore name, and you notice that it put an H on this, on the Harold, but it did not put a capital N on Nelson. Okay, upper underscore name is lower underscore name dot upper. Print upper underscore name, and now everything is an uppercase letter. Okay, take a look at that. Make sure you got the same thing. Then let's go on to the next exercise. Use find to locate the position of the blank space in my underscore name as blank underscore pos underscore 2. Test for the equality of blank underscore pos and blank underscore pos underscore 2. So before we located the blank position manually by counting through the letters in the name and finding out where the blank position was. Okay. Stop the video, do your work, and come back. Okay, you're back. I assume that you have done the work. Let's go look at the next exercise. Or let's look at the answers to this one. myname.find, blank underscore pause underscore 2 is myname.find, and the thing that you want to find is the blank space. And that will locate the index of the first blank space in the string my underscore name. And I ask, is that the same thing that I got before, which was 6? Yes, that equality is true. Okay, let's go on to the next exercise. Create a function check which returns true if a name ends with sen or son and returns false otherwise. Test your function with the names Johnson, Smith, and Anderson. So what we're doing, we're looking for Scandinavian patronymics. Okay. Stop the video, do your work, then come back and look at my answer. Okay, you're back. I assume you've done your work. And here's my function. Check is a function of name, and we're using the method ends with. Result is name.ends with son, S-O-N, or name.ends with sen, S-E-N, and you return result. So I check Johnson. Yeah, there's the S-O-N. I get true. I check Smith. Nope. That's false. I check Anderson. That's true. Okay. Look at that. Make sure you understand why it worked. And we'll go on to the next exercise. One salient characteristic of strings is that they are immutable. Once a string is created, its value can't be changed. Try the following code in CoCalc and observe what happens. It attempts to capitalize a string. So try that. Do your work and come back and we'll go on. Okay, I'm not going to show you what happened in CoCalc, but try this code in CoCalc and see what it does. I start out with the string equal to the lowercase letters A, B, C. Then I say S, the same name, is capital A plus the original string S beginning at the second position to the end, and I print S. Does that work? Well, try that in CoCalc. Okay, you're back, having stopped the video, going over to CoCalc and do that, and I'm sure that you found that that worked just hunky-dory. So, did I get away with violating immutability? There's a reading here you can look at. And let me summarize what the reading says. In Python, there are 3 distinct things: a name, an object, and a value. You can't change a string object, but you can reuse a name to point to a different object. So when we apparently violated immutability, what happened is that we saw the same name S, but the name S referred to a different object at the beginning of that code than it did at the end. Okay, this is one object S. This is a different object S. This is not the same object, it's the same name. That's a confusing point. So it's a wonderful point, though. It enables us to use our accumulation pattern to build a string by starting with an empty string and adding to it by concatenation. Use this fact to write a program to start with a string, use this fact, and build a string consisting of all the vowels in the original string. Note, start by creating a string consisting of all the vowels, both uppercase and lowercase. And remember that the operator in can test for the presence of a character in a string. Okay, so this is a bit of probably a little bit longer exercise. This one will take you a few minutes. But again, as usual, what do I want you to do? I want you to stop the video, do your work, and then come on back and look at the way I did it. Okay, you're back. I hope you succeeded. Let's take a look at my solution. So vowels is A-E-I-O-U, A-E-I-O-U. The string S is use this fact. And the string res starts as an empty string. There's nothing in this thing, but it is a string. So for I in S, if I is in vowels, concatenate the current value of res with I. Then when you're done, after you go through all this for loop, print res, and you can see what it did. The U, yes, that's a vowel. S is not. E is a vowel. Blank space is not a vowel. T is not. H is not. I is a vowel. S is not. Blank space is not. F is not. A is a vowel. And C and T are not, so what you get is U-E-I-A. Okay, that's the end of this set of exercises on strings.